At some point between myth and science, the Megalodon became an idea impossible to kill. No matter how many books say extinct, no matter how many times it is repeated that it disappeared millions of years ago, the name comes back again and again, as if the ocean needed an official monster. And the reason is simple. The Megalodon was not a big shark. For an extremely long geological time, it was the dominant predator of warm seas and coasts rich in food. An animal that does not fit the human scale. When one imagines teeth the size of a hand, a mouth capable of tearing through bone as if it were cardboard, and a body built to hunt marine mammals, the mind does what it always does. It tries to complete the picture with terror, with movie, with legend. But to understand whether the Megalodon could still exist today, we first have to examine a very common trap when talking about this impressive predator. The mental image that almost everyone has of the Megalodon. For decades, it was depicted as a giant great white shark, an enlarged copy of the modern great white. The comparison seemed logical, triangular, serrated teeth, the role of super predator, hunting large prey. The problem is that this logic was too comfortable, and when science becomes comfortable, it is usually one step away from being wrong. In recent years, the Megalodon began to change shape, at least in our understanding. Instead of a compact body, like a muscular torpedo as the great white has, the most recent reconstruction suggests something more aerodynamic and elongated, more similar in overall proportions to modern sharks with a sleeker silhouette. This is not an artistic whim. It is based on anatomical comparisons with dozens and dozens of species, living and extinct, to estimate how the actual body volume was distributed, where the mass was concentrated, and what type of stability it needed to move. And here appears the detail that changes the tone of the mystery. If the Megalodon was more slender than we thought, then its length could probably have been greater than we imagined with the giant great white model. That is to say, by correcting the shape, the scale can grow. However, this must be said calmly. The Megalodon is famous, among other things, for the fragmentary nature of its evidence. We do not know it from complete skeletons hanging in museums like a dinosaur. We know it above all from its teeth, and the teeth, although extraordinary, tell a partial story. They are hard clues of a soft animal. Cartilage, unlike bone, does not leave such a generous fossil record. That is why every rare finding of associated vertebrae or more complete structures becomes extremely valuable. It is like finding whole pages in a book of which we usually only preserve scattered words. With those extra pages, the image of the Megalodon becomes less monster and more machine. A gigantic animal, yes, but with concrete physical and energetic requirements. Because a predator like this cannot exist just by being fearsome. It has to be sustainable. It has to convert food into movement and movement into hunting. In the real ocean, a super predator is not the one who bites the hardest. It is the one who manages to repeat its success day after day. And this brings us to a very important fact. The Megalodon was not just a large animal, it was an ecological phenomenon. To maintain a body of that caliber, it needed calories like someone needs oxygen. It had to live where food was not a rare event, but a routine. Simply put, it needed productive areas, with abundant concentrations of large prey and migration routes where hunting was worth the effort. It is no coincidence that most fossil teeth appear associated with regions that, at the time, were coastal environments or continental shelves. These are places with abundant life, with denser food chains, with marine mammals coming and going, with offspring, with migrations. A giant cannot afford to live in a desert. But then, if biology seems so tied to prey availability, why does the idea that it still exists refuse to die? Because the other half of this story is not in the rocks, but in human experience. When someone says they have seen an impossible shark, the phrase does not face only data, it faces an emotion. The open sea has a special ability to distort scales. Waves hide and reveal. Shadows stretch. A large body seen from a boat becomes bigger if it appears near the surface, if it passes underneath, if the water is murky, if the observer panics. And yet there are reports that became part of the modern folklore of the Megalodon because of their narrative power. Entire groups of witnesses, coinciding descriptions, real fear, and a sensation that sticks like salt in memory. That was not normal. The problem is that the ocean is perfectly capable of producing abnormal encounters without needing to resurrect extinct species. Exceptional great white sharks, enormous basking sharks, whale sharks of enormous size, even sick animals or those with pigmentation anomalies that make them unrecognizable to untrained eyes. And above all, an inevitable human bias. When a mythical name is available, the brain tends to use it as a label. If someone sees a gigantic shark, the first mental box that opens is not extreme natural variation, it is Megalodon. But if the Megalodon is truly extinct, then an inevitable question arises. Why does the story insist on coming back? It does not return with fossils or complete bones, but with accounts, with the feeling that the ocean can still hide something too big, and with a phrase that appears again and again in different languages, in different ports. I saw it. It was impossible. One of the most cited episodes occurred in 1918, off Port Stephens on the coast of New South Wales. Lobster fishermen, people who knew the sea and depended on it for food, described a ghostly great white shark of absurd size. Some spoke of tens of meters. The unsettling part of that case is not only the size, but the human detail. Seasoned men who, according to the account, preferred to risk ruin rather than go out again. And as happens with stories that become legend, the researcher appears. Separate interviews appear. The idea of coherence appears. And the mystery appears. What did they see? Here is where the topic splits into two worlds. One is emotional, the sea as a stage for the unknown, and the Megalodon as the perfect symbol of the ultimate predator. The other world is biological and physical, cold as deep water. If such an animal existed today, the ocean could not hide it as if nothing. In recent years, reconstructions have been published showing it as less robust and more elongated, more similar in proportions to modern sharks with a streamlined body. And that change, paradoxically, does not make it easier to hide. It makes it more realistic as an animal and more demanding as a system. A large predator is not just big, it is a walking energy factory. It breathes, swims, regulates temperature, moves in a dense medium, accelerates, stops, recovers. Everything costs calories. Then the internet's favorite theory appears. It's in the depths, the Mariana Trench, the abyss, the place where we hardly look. The logic seems impeccable. If we haven't found it, it's because we don't know how to look. Besides, the ocean is immense and still unknown. And yes, it's true. There are areas of the seabed that we know less about than the surface of other planets. But one thing is that the ocean hides new species, and another is that it hides a breeding population of super predators weighing tens of tons. The first blow against the idea of the abyssal Megalodon is simple: food. Extreme depths are an energy desert compared to continental shelves and productive areas where marine mammals and large fish concentrate. An animal of the size attributed to the Megalodon needs large, fatty prey. In popular imagination, it is seen hunting whales, seals, dolphins. That does not happen at 8,000 or 10,000 meters where life exists, but on a different scale. Smaller animals, less available biomass, less energy circulating. And if the Megalodon were a predator that could also keep its body somewhat warmer than the surrounding water, a huge advantage for hunting and migrating, that somewhat warmer becomes extremely costly in waters near 2 to 4 degrees Celsius. The second blow is pressure. At abyssal depths, pressure crushes. The creatures that live there are not simply normal creatures in the dark. They are organisms adapted to that physical limit. And a large shark, with its physiology, buoyancy, and need for constant movement, would have to solve problems that cannot be solved with mystery, but with anatomy. But the third blow is the most forceful: the traces. Sharks do not keep their teeth as treasures. They lose them. They replace them, over and over, throughout their lives. A large animal, over decades, leaves a rain of extremely hard and durable pieces. If megalodons existed today, even if they spent part of their time away from the coast, the planet should be finding recent teeth. Not teeth that appeared on a beach and turned out to be fossils, but modern teeth with a different texture, mineralization, and chemical history. And they do not appear, nor does the following: ecological impact. A super predator is not an anecdote. It is a reorganization of behavior, where there is a dominant predator-prey change. They migrate differently, they group differently, they defend differently, they leave marks. And if that predator hunts large marine mammals, it leaves clear signs on bones, wounds, and mortality patterns. The fossil record does show bites attributed to the megalodon in ancient cetaceans, but in the modern world, with monitored whales, analyzed strandings, and hyper-observed marine biology, there is no consistent signature shouting, "A giant predator is eating this." And there is still one more uncomfortable argument, because it does not kill the myth with data. It kills it with population logic. For a species to survive, a hidden individual is not enough. There must be enough individuals to reproduce, maintain genetic diversity, compensate for mortality, and find mates in an immense ocean. That enough is usually far more than a few. And the larger the animal, the slower its reproduction tends to be. That makes hiding it even harder, because you are no longer hiding a solitary monster. You are hiding a network of life that eats, moves, reproduces, and leaves traces. So what do we do with Port Stevens? What do we do with reports of something huge appearing from time to time? The most honest answer is not to mock nor to surrender to mystery. It is to accept that the sea produces perfect illusions, impossible perspectives, shadows under the hull, known animals seen under unusual conditions, distortion from waves, distance, fear. A large great white shark, seen poorly, can look like a submarine. A whale at a strange angle can look like a shape that fits nothing. And when a story is born on a dock, it grows with each repetition. It is polished. It becomes sharper, more cinematic. Not necessarily because of lies, but because of memory. The megalodon, moreover, has a brutal narrative advantage. It doesn't need a body. It needs emptiness. It needs the idea that there is still space in the ocean for the impossible. That is why the story does not die, even when the evidence remains firm. Because it is not competing against a fact. It is competing against an ancient, almost childlike human emotion of looking at a dark horizon and thinking, down there is something. If the megalodon is not hidden in an impossible trench, then the question becomes more uncomfortable and more interesting. How does an animal that seemed invincible disappear? Because the megalodon was not just any predator. It was not a big shark. It was an extreme evolutionary design. Colossal size, a bite capable of breaking bones as if they were dry branches, serrated teeth made to cut flesh and pierce ribs, and a life built around a simple and brutal idea. If the ocean is full of large prey, I will be the one to turn them into food. The problem is that oceans are not a fixed stage. They are an immense machine that changes rhythm. And when that machine changes, the animals at the top are not always the ones that endure best. Sometimes, precisely because they are at the top, they are the first to fall. Because living as a super predator means depending on a very specific chain of conditions. You need abundant prey, wide hunting routes, coastal areas that function as nurseries for offspring, and an ecological balance that allows you to spend energy at a very high rate without running out of fuel. For millions of years, the megalodon had that fuel. The marine world of the Miocene was, in simple terms, a grand banquet. There was a diversity of marine mammals. There were lineages of whales that no longer exist today. There were primitive seals and dolphins. There were large fish, and there were seas with temperatures and currents that supported very productive trophic networks. A giant predator thrives in such a system. The bigger you are, the more profitable hunting large prey can become, because a single catch can sustain you for days. But the banquet does not last forever. Toward the end of the Miocene and the beginning of the Pliocene, The planet began to change in ways that at first glance might seem slow, but at a biological scale can be devastating. Global climate cooled, currents reorganized, and sea levels fluctuated strongly. And this not only changes the water temperature, it changes where life is concentrated. It changes where animals are born and raised. It changes which migration routes become viable. It changes how much food there is and in what places. And here a key point appears. The Megalodon did not need some food. It needed a lot of food always. An animal of that size, moreover, is not just muscle and teeth. It is maintenance. It is movement. It is body heat if, as several lines of evidence suggest, it could maintain an internal temperature above the water. That advantage, which made it more active and more flexible to hunt in different environments, can also become a trap when food becomes scarcer. Being efficient matters. Being adaptable matters. Being small, suddenly, matters. In that context, what is seen in the fossil record and in ecosystem changes is a kind of progressive blackout, not like a final explosion, but like a chain of losses. First, large prey begin to change. Some decrease, others go extinct, others relocate. Second, coastal seas, which are usually rich in food and also serve as nursery areas, become unstable due to fluctuations in sea level. And for many sharks, nursery areas are not a minor detail. They are the difference between having a stable population and collapsing in a few generations. This is easy to understand with an image. Imagine a giant animal depending on specific nurseries, temperate coasts where the young can grow with relative safety and enough food. If the sea rises and falls and reshapes those coasts, if platforms and bays are lost, if currents that carry nutrients are altered, you are not only losing territory, you are losing the place where the future of the species is made. And with sharks, reproduction is usually slow. Few offspring, gradual growth, late maturity. That means a bad environmental streak is not a minor hit. It can be a structural blow. While all this was happening, the Megalodon was not alone. And this is the third edge of the knife, competition. In an ocean where food is abundant, a giant can dominate without too many worries. In an ocean where food starts to become scarce, the story changes. A smaller predator can survive on less. It can hunt prey that the giant does not exploit well. It can move with agility. It can adapt to new niches faster, and above all, it can stay alive while the giant runs out of margin. That's where the great white shark comes in, not as the killer of the Megalodon in a movie fight, but as a competitor at the worst possible moment. Real competition in nature is almost never a direct fight. It is something colder. Who gets enough food when food decreases? Who grows faster? Who needs less? Who can exploit different prey? If the ecosystem becomes harsher, size stops being a crown and becomes a debt you cannot pay. And it's not just the great white. There are also toothed cetaceans, intelligent predators capable of hunting in groups that could compete for resources in a changing ocean. The important idea is not to imagine one species against another as a war with clear winners, but to understand that the pressure came from several sides at once: fewer available prey, altered coastal habitats, and a community of more efficient predators growing in a world that began to reward efficiency over brute power. Now, when speaking of extinction, another detail appears that feeds the myth: the when. For years there were different estimates, because the shark fossil record is dominated by teeth, and teeth move, are reworked in sediments, mix in younger layers, and are found out of context. This makes it so that, if not analyzed carefully, it seems there are younger remains than there actually are, and there the illusion arises. If there are young teeth, maybe it survived. Reality is more prosaic and more demanding. When filtered by reliable provenance and redeposited material is discarded, the time window closes. And when that window closes, what remains is a story less fantastic but more powerful. The story of a king who was not defeated by a rival, but by a world that stopped resembling the world where it had been crowned. The Megalodon was a perfect product of its time, but its time changed. And with that change, its design, dependent on large prey and coastal conditions, became increasingly unviable. In other words, It did not disappear for lack of strength. It disappeared for lack of ecosystem. Because in nature, even the most fearsome predator is, in the end, a reflection of the abundance that sustains it. Let's imagine for a moment that the Megalodon did not go extinct. Not as an isolated individual, not as a solitary rarity that appears once a century, but as a real species, with a population large enough to reproduce, survive diseases, raise its young, and maintain genetic diversity. That is the only way that still existing makes biological sense. And when framed this way, the question stops being romantic and becomes logistical. Because a super predator does not live hidden. It lives operating. It eats, it moves, it leaves traces, it interacts with its ecosystem and modifies it. In today's ocean, that trace would have to be as visible as a wake, even if the animal never allowed itself to be filmed. The first trace would be material, physical, inevitable. Teeth. Sharks produce teeth as if they were ammunition. They lose them, replace them, renew them throughout their lives. A gigantic, long-lived animal that feeds on large prey and stresses tough tissues would lose teeth regularly. And those teeth would not be pretty beach fossils, polished by time. They would be modern teeth, with a different texture, a different chemistry, a different wear history. On a planet where ports are dredged, sediments analyzed, sea floors explored with scientific equipment, and the sea worked daily with nets and long lines, that kind of finding could not remain a recurring rumor without becoming repeatable evidence, but it does not appear. And when recent teeth show up in dubious reports or publications, the pattern is usually the same. Weak datings, poorly interpreted geological context, pieces reworked by currents that end up in deposits much younger than their real age. The ocean moves things. The earth rearranges layers. And the confusion between found today and formed today is a perfect myth-making machine. The second trace would be ecological, the hunting signature. If the Megalodon lived today, it would have to eat a lot. And because of its size, the most efficient diet would be the same that made it famous. Large, energetic prey with fattened muscle. That means marine mammals and large fish. But the modern ocean has something the Pliocene ocean did not: intensive monitoring of cetaceans and a growing record of strandings, necropsies, scars, mortality patterns, and wounds. Yes, there are shark bites on marine animals. Yes, there are impressive predation events. But what is not there is a consistent new pattern that would force biologists to invent an unknown predator of enormous size to explain it. An animal like that would not leave a discrete bite. It would leave a signature. Cuts, fractures, tissue separations, and marks of a size that simply would not match current predators. And most importantly, that signature would appear again and again, in different locations, with enough repetition for the issue to stop being an internet debate and become a zoological crisis. The third trace would be technological, because the ocean is no longer that stage where the unknown lives simply because no one looks. Today, it is observed far more than people think, even though the sea remains vast and mysterious. There is industrial fishing with observers, records of bycatch, photographs, documented landings, satellite monitoring of vessels, scientists placing tags and transmitters on large sharks, research networks comparing movements and presence zones. And, moreover, there is a tool that changes the game: environmental DNA. Water is not just water, it is an archive. An animal that passes through an area leaves cells, mucus, traces, microscopic fragments. Today it is possible to sample water and detect species without seeing them. This is already used with great white sharks and many other marine species. So, if a giant shark species were alive and moved through productive areas, sooner or later it would appear in those samples, not as a blurry photo, but as a genetic sequence that does not match anything known. And there is still a fourth trace, the most forgotten, the demographic trace. For a large species to survive long-term, it needs numbers, not necessarily thousands, but enough to avoid a lethal genetic bottleneck. And those numbers impose an unavoidable reality: juveniles, offspring, nurseries, areas where the young grow and are most exposed. That is where most large animals become visible, because adults can cross oceans. Juveniles usually depend on specific areas. If a modern population existed, somewhere on the planet there would be zones where young megalodons were growing, learning to hunt, moving in shallower or more accessible environments. In a world with drones, underwater cameras, marine tourism, coastal fishing, and citizen science, those juveniles would be the link most likely to break the secret first. At this point, the favorite defense of the myth usually appears. It lives in the deep and almost never comes up. The problem is that this does not solve the equation, it makes it worse. Extreme depths are not a supermarket of calories. They are in general a low-energy environment compared to continental shelves and areas where large prey concentrate. A colossal predator could visit deep areas, yes, but it cannot base its existence in an energy desert, especially if its physiology includes advantages like maintaining its body warmer than the surroundings. That relative warmth helps it be more active, but it comes at a cost. It is a permanent tax, and the deep sea, cold and poor in large biomass, is the least forgiving place to pay that tax without breaking. Another common defense is, there are species we don't know about. Of course there are. New species are described every year, but almost always they are small, discrete animals, hard to distinguish, or inhabitants of extremely specific niches. The megalodon is not that. It is an animal that by definition cannot exist without exerting a gigantic impact on its ecosystem. It is not hard to see. It is hard to sustain without the world noticing. The argument of conspiracy also appears. If they found it, they wouldn't tell. But the ocean is not a closed laboratory. It is a global network with thousands of actors. Universities, museums, fishermen, governments, companies, independent researchers, underwater photographers, civilian vessels. Keeping a secret like that would not depend on hiding a single photo. It would depend on hiding thousands of traces in a coordinated way over decades. Modern teeth, environmental DNA, bycatch, new injuries on prey, acoustic records, satellite coincidences. It is asking the real world to behave like a movie. So if the response, "there is no evidence," sounds cold, it is worth turning it around. The evidence that does exist tells a story. A story of extinction well placed in geological time, with windows that have been refined as the fossil record was cleared of contextual errors. A story of climatic and ecological changes that reduce the margin for an extremely costly predator. And a story even of how certain traits that could have been advantages, like maintaining a body temperature higher than the surrounding water, also imply energetic demands that make a species more vulnerable when the ecosystem changes. The question, could it still exist, actually splits into two. If the question is, could a large unknown shark exist? The answer is, there is room for surprises, especially in the deep ocean, and science is always open to the unexpected. But if the question is, could the Megalodon exist today, this colossal super predator of the past without the modern ocean revealing it? The answer becomes almost a mathematical conclusion. It would have to have a viable population, it would have to feed on a large scale, it would have to leave modern teeth, it would have to appear in environmental DNA, it would have to produce a recognizable predation pattern, it would have to have juveniles somewhere, and it would have to coexist with a humanity that for the first time in history stopped looking at the ocean only with eyes and began to look at it with data. And yet the myth persists for a reason more human than scientific, because it is a form of respect. The megalodon became the modern way of admitting that the ocean is still too vast for us, that there is a dark edge where imagination feels comfortable, that the natural world was capable of producing predators so extreme that even extinct, they still seem too much to be true. But reality does not need the megalodon to still be alive to be unsettling. Reality already has enormous sharks, migration routes that cross continents, fragile ecosystems that change with the climate, and a sea that still holds secrets. Only that secrets, when they are giant, are not sustained by faith. They are sustained by evidence,